So we're going to go through exponent loss, and we'll talk about each law and then just show you a very simple example to accompany them. So in the first law, what this is saying is as long as the bases of the exponents are the same, when we're multiplying, we can simplify by keeping the same base and just adding the two exponents together. So an example of that would be, let's say we have 3 to the power of 2 times 3 to the power of 4. We can simplify it by writing 3 to the power of 2 plus 4, which is 3 to the power of 6. Okay? There's our first one. Same idea with division. Remember that fraction means division sign. So if we have two bases that are the exact same, and we're dividing them, all we have to do is write it as one single base, and then we subtract our two exponents. So the opposite operation of when we're multiplying. Let's use those same two values. Let's say we have 3 to the power of 2 over 3 to the power of 4. We can rewrite this as just 3, the base, and we always take the exponent on top to start. So because we had the 2 first, we start with 2, subtract 4. 2 subtract 4 is going to be -2. So our answer is -2. And we'll talk about how to change negatives into positives after. Okay. Our third rule here is a power of a power. So you're only going to have one base in this question, so the base is going to stay the same. But it's when we have an exponent, and then all of that is to another exponent. In which case, we just multiply the two exponents by each other. So let's say we have 3 to the power of 2 to the power of 4. We can rewrite it as 3 to the power of 2 times 4, which is 3 to the power of 8. And finally, the last example is if you have a base to a negative exponent and we want to make it positive. Now, your book will show you several ways of doing this, but I want us to think of fractions when we do this. I can write any whole number as a fraction by putting it above 1, correct? So really think of this as all the things in this bracket, x over 1 to the power of -a. So I'm actually going to write that in. Over 1 to the power of -a. Because we can make any whole number a fraction. To make it positive, the exponent, we invert the fraction. We bring the 1 to the top and whatever number to the bottom, and then the exponent becomes positive. So let's walk through this process together. Let's say I have 3 to the power of -2, which was our answer from up here, and I need to make it positive. I'm going to make the base, which is 3, a fraction. So as a fraction, how do I write that? 3 over 1. Okay? So what this says is 3 over 1 to the power of -2, but I need to make it a positive exponent. So I have to invert it. When I invert it, what does it become? 1 over 3 to the power of +2. And now we have a positive exponent. Okay, so this example is going to encompass all of our rules. To start off, all of the bases are the same, so we know we can use our simplifying rules. The very first one is multiplying bases that are the same. So we can simplify that by just writing it as the base of 5 and adding those two exponents, so 2 plus 3. Okay. On the bottom, we're going to try to do this quickly, we have a power of a power, which means we multiply the exponents and still keep the same base. So that becomes 5 to the power of 8 times 2. A little different. This will leave us with 5 to the power of 5 over 5 to the power of 16. That leaves us with one last rule, a division question. And because it's dividing, we need to subtract our exponents. So we have 5 to the power of 5 to start, subtract the exponent on the bottom, which is 16, which leaves us with 5 to the power of -9. Oh, sorry, you're right, it is -11. But it's a negative exponent. I need to make this a positive exponent. So we talked about this. I'm going to turn it into a fraction. And to make this a positive exponent, I'm going to invert that fraction. So this becomes 1 over 5. And now our exponent of -11 can be written as a positive exponent of 11.